video. In this video, I'm going to work an example where we graph an exponential function and state key function characteristics. And we're going to be working with this in class on Tuesday. So here's our function, f of x equals -4 plus 3 to the power of x plus 2. So let's write, first of all, let's write this in kind of a more standard form. So I'll rewrite it, f of x is equal to, so I'm rewriting it in a more standard form because here are the constants first. So I'm going to write the exponential term first, 3 to the x plus 2 minus 4. And this is very similar to our, let me write the transformation underneath it. F of x is equal to a times b to the c times x minus h plus k. So now we want to figure out what A, B, so A, B, C, H, and K are. So A is equal to 1 because that's what's multiplying 3 there. So A is equal to 1. So that means we have no vertical reflection or dilation. Yay. The base. That is what the exponent is attached to. The base is equal to 3. So here the base, here. So the base is equal to 3. So what does that mean? Base is equal to 3 means that it's the base, it's greater than 1. So this is growth. And that growth factor is 3. The growth rate is going to be 2, or 200%. C is what's multiplying x minus h. So here it looks like if I put parentheses around the x plus 2, it's being multiplied by 1. So C is equal to 1. And so that means that there's no horizontal reflection. That's nice. And then finally h. H is what's being subtracted from x. And so we have x plus 2. So what's being subtracted from x? That's x minus -2. So h, our horizontal translation is -2. So that means that it's translated 2 to the left. Finally, we get k. K is the constant term that's all by itself. And k is right here. K is right here. So k in this example is -4. So that means that we've been translated down by 4. Okay, so now we've identified all these transformation parameters. Now we need to we need to translate the function. Since the function hasn't been dilated or reflected, just translated, this is really, really nice. So what I'm going to do first is, I'm going to get, let's go to dual page on, and I'm going to just give myself some scribble room here, x, y. But I'm going to graph y is equal to 3 to the x. That's my parent function. So if I do like -2, -1, 0, 1, 2, I get 3 to the -2 is 1/9, 3 to the -1 is 1/3, 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9. So my parent function I'm going to graph here in black. 0 up 1, and then I have 1, I have some very small values over here, and then I go over 1 up 3. That's the wrong thing. So I'm graphing first thing I'm graphing is my parent function, which is going to be 3 to the x. It's just the base, whatever base I have, to the power of x. So over 1 up 3, 1, 2, 3, and then over 2 up 9. And so that is my parent function. Let me get a skinny line to graph that with. So here's my parent function. It has a horizontal asymptote, that's the y-axis, and it goes up like this. But now I need to translate this function. I need to translate it 2 to the left, and then I need to translate it 4 down. So every single point here, so point 29, this point 29, it's going to, so here's 29, it's going to translate 2 to the left, and it's going to go 2 to the left, and then it's going to go 4 down. 1, 2, 3, 4. 2, 5. And then this point, 1, 3, right here, it's going to go 2 to the left, 1, 2, and then 4 down. So it's going to go down here. This point, 0, 1, it's going to go 2 to the left, and then 4 down to -3. And then what happens to our horizontal asymptote? Our horizontal asymptote is going to shift down by 4. So HA moves down by 4. So it's going to move from the x-axis to y is equal to -4. So there is our HA after transformation. Y is equal to -4. So y equals 0, down 4, to y equals -4. And so now we've moved every point that we plotted. We moved it down, or left 2, down 4, and we moved our horizontal asymptote. And now we can just sketch in this function. Boom. We've used transformations to transform this function from the parent function, which was 3 to the x. So the parent was 3 to the x. We graphed the parent, and then we looked at this function rule and identified all of the transformation parameters. And then we shifted the points that we'd graphed. We shifted them according to the transformation parameters. We shifted the horizontal asymptote according to the transformation parameters, and we got this new graph, which is our transformed graph. Here is a graph that I came up with of this function using my TI calculator. Y is equal to, I typed in this rule, and you can see I pretty much have the same. Well, this one's prettier than my manual graph, but my manual graph pretty much captures that. So key function characteristics that need to be listed. The domain, once again, it's going to be all real numbers. The range has changed. Since the horizontal asymptote moved down by 4, the range is now going to be from -4 to +∞. We have our horizontal asymptote is shifted down by 4. So the horizontal asymptote is y equals -4. The function is increasing everywhere. It's decreasing nowhere. And we have the y-intercept. We calculated that. It ends up being it ends up being over, so one of these points, I think it was 3, 1, or no, actually it was this one, yeah, 9, 2. We went left 2, down 4, so it looks like the y-intercept is going to be 0, 5. You could evaluate that from the function by just doing f of 0, and f of 0 is going to equal -4 plus 3 to the 0 plus 2. So it's -4 plus 3 squared. 3 squared is 9, so -4 plus 9, which equals 5, which is our y-intercept. So you can get the y-intercept from the graph, or you can get it analytically. The x-intercept, now we do have an x-intercept. Good Lord, how do we find that? Well, the x-intercept happens when the output is 0, so 0 is equal to -4 plus 3 to the x plus 2. So you have to solve for x, so get everything where x isn't on one side. We get -4 is equal to 3 to the x plus 2, so I guess that would be plus 4. And now the exponent is buried, the variable's in the exponent, and we need a tool to get the variable out from the exponent. And that tool will be logarithms. So we need logs to solve. and algebraically. You can find, if you have mad calculator skills, you can find the x-intercept using the graphing calculator, and I'll show you how to do that in class. That's pretty much it for exponential functions and transforming them. We'll do some practice in class. Thank you for watching the video and taking good notes, and I will see you there. Oh, that's the homework from last year. You don't have to do it. Bye.